Money deposited in a bank account earns interest on the initial amount deposited, as well as any interest earned as time passes. This compound interest can be described by the expression of the product of P and the sum of 1 plus R raised to the nth power, where P represents the initial amount deposited, R represents the interest rate, and N represents the number of years that pass. How does a change in each variable affect the value of the expression? Let's write down the expression. So we have P multiplied by the sum of 1 plus R raised to the nth power. Now, we can definitely see that this expression is the product of two factors. So the factors of the expression are P and 1 plus R to the nth power. Changing the value of P does not change the value of the factor 1 plus R to the nth power, but it will change the value of the expression by a factor of P. In other words, if P alone is double, then the value of the whole expression doubles. Likewise, if the term 1 plus R raised to the nth power is doubled, then the entire expression doubles. Let's set our initial amount in our bank account at $100. So let's set P equals $100. And let's say my interest rate is 10%. So my rate is equivalent to 10%. So let's write that out in the expression. My expression would be 100 times 1 plus 0.1 raised to the nth power. Let's simplify the expression. So we'd have 100 times 1.1 to the nth power. Let's create a table to see how changing the variables can impact our expression. So once again, we start with an initial amount. So year 0, we'll call this year 0. And our amount would be 100 multiplied by 1.1. Remember, we're taking a 10% interest rate raised to the 0 power. And that is equivalent to $100, because anything raised to the 0 power is 1. So 100 times 1 is 100. Let's take year after 1 year. So we'd have 100 multiplied by 1.1 to the first power. And that would be equivalent to $110. Let's take year 2. Year 2, we would have 100 multiplied by 1.1 to the second power, which is really year 1 multiplied by 1.1. So we would take 110 multiplied by 1.1, and we'd have $121. So we can see that doubling N didn't necessarily double the final amount. In other words, we changed from 110 to 121 by doubling N from a number of 1 to 2. Let's try year 3. Year 3 would be equivalent to year 2 multiplied by 1.1, or 100, 1.1 raised to the third power. In other words, this is equivalent to $121 multiplied by 1.1, which is equivalent to $133.10. Now, the word compound in this problem, compounded interest, is the amount earned on the principal sum plus the previously accumulated interest. In other words, we're earning interest on the interest because we're keeping that interest in that account. Next, let's go ahead and analyze the impact of changing the variable R. So let's say I double R. So in year 0, I would have 100 times 1.2. We'd have 20%. So let's put down that 20%. And it would still be $100 because 1.2 raised to the 0 power is 1, and 100 times 1 is 100. So let's take year 1. We'd have 100 times 1.2 to the first power. And that would be equivalent to $120. Let's try year 2. We would have 100 times 1.2 to the second power, which is equivalent to $144. So let's compare that year 1, 20% with the year 1 of 10%. So $120 compared to $110. So it went up, but it didn't double. Let's look at year 2. At 10%, we had $121. At 20%, we have $144. So like we said, it's not doubling, but it is going up. Lastly, let's analyze what the impact is of changing the variable P, the initial amount. So in year 0, let's double the initial amount to $200. We're investing $200 now at an interest rate of 1.1 to the 0 power. So we would have $200 for our initial amount. At year 1, after 1 year, we would have $200 times 1.1 to the first power. So 200 times 1.1 is equivalent to $220. That is double the amount of year 1 at an investment of $100. So we can see that it doubled. Let's just try year 2 to make sure. So year 2 would be 200 times 1.1 to the second power, and that would be equivalent to $242, which is double the amount of year 2 when we had an initial amount of $100. Therefore, doubling P would double the expression. Tripling P would triple the expression, and so on.